All right, guys, if you do not have your notebooks out, go ahead and take them out, and where we should have green on the left, notes on the right. So take that out right now if you don't have them out, where we can take down our vocab words for the day. Green on the left, notes on the right. All right, here we go. Vocabulary. All right, it's on chapter 4 vocab sheet that you guys grabbed on Friday. All right, here we go. All right, our first word for today's lesson on decimal and fraction conversions would be repeating decimal. So repeating decimal, everyone. Okay, so a repeating decimal is the decimal form of a rational number. The decimal form of a rational number. So go to your little box on the side and just go ahead and fill this example in. There it is. It's just 0.121212. And we'll talk about this in a second, but the last two digits, the 1, 2, has a line over the top. All right. Our next word or phrase is bar notation. So bar notation, everyone. All right, so bar notation, here's what the book says. In the back it says, in repeating decimals, it's the line or bar placed over the digits that repeat. All right, so again, if you want to write down the exact same thing, 0.121212, obviously the 1, 2 are the two digits that are repeating, so that's why it's a little more bold. Okay, showing that it's in bar notation. The bar is over the 1, 2 because those are the two digits that repeat. All right, our third and our last phrase for today's lesson is something called terminating decimal. Everyone? All right, so here's what the book says a terminating decimal is. It's a repeating decimal which has a repeating digit of 0. A repeating decimal which has a repeating digit of 0. All right, so terminating decimal, it'll pop up a couple times, maybe even on your quiz, so make sure you have this down. All right, we have 0.500 with a line over the 0. It's because the 0 keeps repeating. It goes on forever. Okay. Now, terminating decimals, guys, it can also be written as just 0.5 because you can drop the rest of the zeros if you don't already know that. All right. So, terminating decimal. All right. Terminating means end. So, it's basically a decimal that just drops off or ends. So, 0.5 is just what a terminating decimal is. All right. There's nothing on the end. Or you could figure it's repeating zeros. All right, so that is our vocab. All right, so what I want you guys to do right now is to go ahead and you could put your binder away. Go ahead and grab your book. Turn to page 267. 267. $267. All right, so here we go. On 267, if you don't have your book out, let's get it out. 267. All right, let's go ahead and our first problem we're going to do together is problem number 10. Problem number 10. All right, so of course, make sure you read the directions. All right. Up top it says, write each fraction or mixed number as a decimal. Use bar notation if needed. All right, so here we go. Number 10. All right, so number 10 says negative 1/6. All right. Now, what we're doing is we're going to take this fraction and we're going to make it into a decimal. All right. On Friday when we made our number lines, we talked about how in between, for example, 0 and 1, you have fractions or decimals, and they're exactly the same thing. It just is written in a different way. All right. So we're just going to make this negative 1/6 look like a decimal. All right. So here we go. On number 10, go ahead and put step 1. All right. Step 1 is this little negative here. It actually, when it comes to conversions, we know that it's going to be a negative in the end. Let's just ignore it for right now. So that's step 1. Ignore the negative sign. All right. So here we go. Step 2. All right. Step 2 is we're going to take the denominator, okay, and we're going to divide it into the numerator. So the bottom number into the top number. Okay, so if you don't know what that is, here's what it is. All right, 6 divided into 1. All right, so 1 becomes our dividend, 6 is our divisor. All right, so here we go. After we divide that into there and rewrite it, I should say, all right, part of step 2, of course, is just finish dividing. So here we go. 6 into 1. Now we know that 6 doesn't go into 1, right? So we need to make, this is where the decimal comes in. We go ahead and put 0.0. Kind of like that terminating decimal, right? Can have a repeating 0. So we're going to go ahead. 1 is the same as 1.0. But what it does is it helps us, of course, divide as if it's 6 into 10, even though it's not 10, we just ignore the decimal the first time around. So 6 into 10 would only go, of course, one time without going over. So we multiply 1 times 6 is 6, and then we subtract 10 minus 6, again, ignoring the decimal, 10 minus 6 is 4. Now, obviously, we have a remainder. Okay, and when we're converting it to a decimal, when there's a remainder, that means we put another 0. So all we did was just change 1 to 1.0. Now it's 1.00. Same thing. We're going to just bring the 0 down. Okay, and what we have now is we have 6 goes into 40 6 times without going over. So 6 times 6 is 36. Subtract. If you need to borrow. Okay, that becomes a 3, and then that becomes a 10. And 10 minus 6 is 4. Okay, if you're running out of a line up here, you could just extend it. Okay, we have another remainder. We put a 0, bring it down. And now that I'm looking at this, it's just like last time. So if I go 6 into 40, it's going to go 6 times. 6 times 6 is, again, 36. Subtract. We can borrow if we want, but we're going to get 4. And if you notice, if we put another 0 or bring it down, it ends up that the 6 just keeps repeating. So here's what we're going to do. Why keep going and have a bunch of 6s, right? If we know that it's 6 repeating, we're going to bring up our decimal point. Okay, and that's all division of decimals, of course. Now, we can consider this step 3 is go ahead, rewrite this as 0.16, or what could be 16 hundredths. Because the 6 repeats, right, we're going to put a bar only over the 6, not over the 1, just over the 6, because that's the digit that repeats. Okay. Now, some of us are probably wondering, well, is that a good answer? Yes. Can we put, Mr. Wilkins, can we put a 0 in front? Yep, you sure can. All right, means the same thing. 0 in the 1 spot to the left of the decimal would be okay. And that, of course, is your answer. Okay, so we have step 1, ignore your decimal. Step 2, divide the bottom into the top. So we did that, right? 6 into 1, and it was long division. That's the long step. You have to be patient. Step 3 is rewrite it in bar notation if needed. Okay? However, this, of course, is what we need to be careful with, because even though that was an answer, that's not our final answer, because step 4 is if you drop that negative in the front on the fraction, do not forget to put it back on your answer. Okay, that's a big one. You might want to put a star by step 4 because you have to have that as a negative or else it will be wrong. Okay, so we have is negative 1600ths, bar notation, in bar notation with bar over the 6, just the 6. And that's our answer. Okay. Okay, so here is what I want you guys to try out, all right? And this will take a little while, so I'll give you guys about a minute instead of our normal 30 seconds just because of the long division. Okay, so here's what I'm going to have you do. I'm going to have you go ahead and try problem number 11. Problem number 11. Okay, which is, of course, negative, looking here, negative 8/11. So you're going to convert that into a decimal. All right. Guys, on tonight's homework, just a little note. You might want to write this down before you start number 11. On tonight's homework, only go a maximum of 4 digits, okay, to the right of the decimal. All right, 4 digits to the right of the decimal. You don't have to go any more than that. There might be some that go more than that. Don't go any more than that. Just 4 digits, so where you know. All right. So, negative 8/11ths. All right, let me go ahead and give you guys 1 minute. Number 11, go ahead and go. Okay, with the long division, I'm going to give you guys a few more seconds. All right, not much, but make sure you put finishing touches on there. All right, guys, so here we go. Hopefully you have an answer. All right, go ahead, 30 seconds. Go ahead and turn to your neighbor and share. Go. Okay, so here's what we're going to do. Since I'm not here right now, here's what we're going to do. We're just going to go ahead and you've had your chance to try it out, test yourself out, check it with your neighbor, see what they say. Now go ahead and double check, make sure if you have something wrong, make sure that you're writing this down. Okay, number 11. All right, so step 1, right, there's a negative, we're going to drop it. Step 2 is we're going to go bottom into top. So that means 11 into 8. Okay, we can't do that, right? So we make it look like 80 by putting a decimal point and a 0. All right, so we have 11 into 80. Well, it's not 8 times because, of course, that'd be 88. So we'll go 7 times. I put the 7 over the 0. Okay, we didn't talk about that before, but 7 goes over to the 0. 7 times 11 is 77. And then I subtract. Again, do a little borrowing if you need to. So we have 10 minus 7 is 3. Obviously, a remainder. Okay, so if there's a remainder, we go ahead, put a 0, bring it down. 11 into 30, okay, is, well, 3 would be 33, right? So that's too big. We go 2 times. 2 times 11 is 22. I go ahead and, you don't necessarily have to borrow if you know what 30 minus 22 is and get 8. That's okay. Or you could do borrowing. Okay. And then we're going to go ahead, put a 0, bring it down. 11 goes into 80. Haha, we've already done that before. Let's just check it out, though. I'm not going to stop in case I messed up somewhere. So we go 11 into 80, goes 7 times. 7 times 11 is 77. Again, I can borrow. We get 3, 0, 30. Look at, it's now going to start repeating because I'm going to have to go in that 2 times like we did before. So it's just what's going to happen is we're going to bring up the decimal point. We're going to go ahead and rewrite this over here. So it becomes, put the 0 in the 1 spot if I want, 0.72 or 72 hundredths. Of course, the 7, 2 are both going to repeat. So I put the bar notation over both the 7 and 2. And of course, don't forget step 4. If you did before, we have our negative out front. And that is the answer to number 11. Okay, then let's go ahead and try out problem. Put a line under this. Let's go ahead and do problem number together. We'll do problem number 12. Problem number 12. Okay, with problem number 12, it has 2 and 6/11. 2 and 6/11. So here's what we're going to do. We're going to go ahead and when we do this problem, this is the nice thing, okay? We're going to actually follow the exact same steps as number 10, okay? But instead of dropping the negative, we're actually going to just drop the whole number for now. Because when we're converting, remember, we're only converting the fraction part, which is this part here, to a decimal. And again, step 4, at the very end of the problem, we're going to put this back on just like we put the negative. All right, so to see what that looks like, here's what we're going to do. So we're going to ignore the 2. We're going to go ahead and divide 11 into 6, bottom into top. Okay, I'm going to put decimal point with a 0. 11 into 60 goes, or what looks like 60 goes 5 times. 5 times 11 is 55. I subtract. Borrow if I need to. 10 minus 5 is 5. I'm going to go ahead and put a 0. I have a remainder there, so bring it down. 11 into 50 goes 4 times. 4 times 11 is 44. Do a little borrowing here. 10 minus 4 is 6. 0. Bring it down, and hopefully you guys already realize, look at this, 60. So I'm going to go in 5 times just to try it out, just to make sure I didn't mess up. And borrow if I need to. 10 minus 5 is 5. And if I put an extra 0, I'm going to end up with 50. So it's just going to completely repeat here. So don't forget, bring your decimal up. I'm going to go ahead and bring that over and say, but be careful, instead of putting 0.54, right? Remember the 54 is going to be the 2 that repeat. I'll put a bar over that, but instead of putting a 0, and instead of putting, of course, negative back on, I'm going to go ahead and put the 2 back on. So instead of 2 and 6/11, it's going to be 2 and 54 hundredths in bar notation. And that is our answer for number 12. All right, questions on that? Make sure you ask your sub. All right, so here we go. Let's go ahead. I'm going to have you guys try out one. I'm going to have you try out problem number 2. Problem number 2, guys, on your book, of course, is -4 and 4/25. -4 and 4/25. Go ahead and convert that to a decimal. All right. I'll give you guys. I'll give you this time around. I'll give you about a minute and a half. All right, go. All right, so here we go. This is a little bit of an extra challenge, right? Because we have a negative and a 4 that we're going to drop. So remember, we're only converting the 4/25. So I'm going to go ahead and go bottom and top. So 25 into 4. So what it's going to go, it's going to go into 40. Now, you have to think of the whole thing. I know that 25, like a quarter, if I multiply that with by 2, I'm going to get like 50 cents, right? 25 times 2 is 50. So instead, I'm just going to go in once. So 1 times 25, of course, is 25. So I'm going to go ahead and subtract. Okay, and a little bit of borrowing here. So 3 minus 2 is 1. 10 minus 5 is 5. Okay, put a 0 down. Okay, because we have a remainder, bring the 0 down. Okay. Well, if I'm thinking of quarters here, I would say, well, how many? Well, 4 quarters make $1, which is 100, right? If I have an extra like 50 cents, that's 4 plus another 2 quarters. So that's a total of 6. If you don't believe me, you can just go over to the side, right, and go 25 times 6, 30, 12 plus 3 is 50. That's perfect. So it's 25 goes into 150 exactly 6 times. Now we're done with the remainders. This one has no repeating decimal. It's just 16 hundredths. So I go ahead and bring that over, 16 hundredths. And remember, instead of putting a 0 up front here, we have a whole number this time. And it's just -4. It's a negative number there, negative integer to put in front. So we have -4 and 16 hundredths. Okay. All right. And then our last problem, and there's 3 problems today. Our last one is, let's take a look at problem number 14. All right, so now what number 14 is doing, I'll go ahead and get a new paper here. Move those out of the way. Okay, number 14. Number 14 is says write each decimal as a fraction. So we're going to go back the other way. So here's what we do. This is a little easier. All right, well, maybe. It's just different. So we have 55 hundredths. Okay, now there's a couple of different ways I could do this, but because I'm on video here and I want to make sure it's quick enough for you guys, I'm only going to explain it one way. Here's how you're going to do this. So what you do is you actually, the very first thing you do is you ignore the whole fact that it's a decimal. Okay, and what you do is you're going to go ahead and after you ignore it's a decimal, you're going to take the number that is there, and it's 55, and that is going to go as a numerator or a top number over your fraction. Okay, so when we have 55 on top, now here's what you're going to do. You're actually going to, step 2, you're going to count how many digits are to the right of the decimal. In this case, there's 2 digits to the right of the decimal, and that's actually how many zeros you're going to put in your denominator. So in this case, because there's 2 digits, there's 2 zeros, but that's not all. You're going to, of course, it's not 0 as a denominator. You're going to put a 1 in front. It's actually 100. Okay? And then step 3, the third thing you're going to do after you do that is, and you might want to write this down and remember, and when we're dealing with fractions, you always want to look for this. You always want to try to reduce or simplify. And what I notice is both of these end in a 5 or 0, so I know that I can divide both top and bottom by 5. And I know 55 divided by 5 is 11. 100 divided by 5, well, if I'm thinking about that, 5 goes into 10 2 times with an extra 0 left over, so it's just 20. If you want to check it, right, you can just say 5 times 2 is 10 with the extra 0. So you can multiply that to check it. All right, and then 11 is prime. I can only divide it by 1 and 11, and I can't divide 20 by 1. It doesn't do us any good, but I can't divide it by 11. So that is how you change a decimal to a fraction. Okay, so with that said, all right, I want you guys to try out problem number 13. Problem number 13. So you're converting a negative 2/10 to a fraction. All right, I'll give you guys a minute. Go ahead and do that. Go. All right, guys, really quickly, 30 seconds. Turn to your neighbor and share. Go. All right, let's see if you guys got it right. Here we go. All right, so step 1, remember, is to ignore the decimal. Just write the number as your numerator, okay, which is 2. Okay, now, if I want to, I could make it as a negative 2, or just like the prior time, we could just drop the negative and put it back on at the end on this problem. So we have 2. Now, there is only 1 digit here on the right side of the decimal, so I'm going to put 1 0. And if with the 1 0, I put a 1 in front. So basically, it's 2/10. Okay? If you didn't notice, that's how you say this right here, 2/10. So we have 2/10 as a fraction. Now that one's easy. They're both even numbers, so when they're both even, that means we can divide by 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. Of course, don't forget that negative, and we have negative 1/5. All right, guys. The rest of the time is yours. Get going on your homework.